Hello and welcome. We're going to be talking about parallelograms today. So a couple vocab words to get out of the way. First off is complementary angles. That word complementary implies that your angle is going to add up to 90 degrees. So two or more angles together adds up to a 90. Remember, the symbol for 90 degrees in geometry is usually a little box that you're going to see there, just as a heads up. Now, another one that we're going to use today and use often is supplementary angles, where two or more angles are going to add up to 180 degrees. All right, we also have a couple of just standard vocab for geometry. Quadrilateral is a polygon of four sides. Polygon is just a n-sided shape with no curves, essentially. Okay, a parallelogram is a quadrilateral, so this thing, it has four sides, but specifically two sets of those sides must be parallel. Parallel is denoted by arrows. So if you see two sides, single arrow is parallel to single arrow, double with double. Rectangles is a quadrilateral, specifically also a parallelogram, but in addition you have four right angles in each corner, right? So that tells you that every angle is guaranteed to be 90 degrees. And then last but not least, you have a square, which is the kind of the most stringent there. You have a quadrilateral, which is also a parallelogram, which is also a rectangle, and it's a square if it's all of those other things, but also has congruent sides. Remember, congruent, all the way down here, is two objects that are the same size and shape. In other words, equal, meaning that you have right angles here, but you also have congruent sides. We mark that with a dash, meaning if that side is 4, every side is 4. Okay, and then you can also mark parallel. Okay, so there you go. There is your vocab. Now the theorems we're going to be using today is 4 of them. Now the first one is going to be that opposite sides of your parallelogram are congruent, meaning the opposite sides that are parallel to each other are also equal in length. You can also say something about the angles, that opposite angles are congruent. So if this was 70 degrees, you would also be guaranteed to have 70 degrees across from it. Your third is only going to apply to diagonals of the parallelogram, and those diagonals bisect each other. Bisect essentially means that it's divided into two congruent parts. So you have your midpoint, but that means that this section is congruent to that one, right? So that segment is congruent to the other segment. Okay, so that's what it means to bisect. You're guaranteed that those two are equal sections when you cut it. All right, and then the next is the adjacent interior angles are supplementary. So we know that angles that are opposite are congruent. That means that angles that are adjacent, meaning A and B, that's next to each other, right? You're guaranteed that those two add up to 180 degrees, aka supplementary. And that is also true for the angles like A and D. You're also guaranteed that A and D also add up to 180 degrees. Okay, so that's all of your vocab for everything parallelograms. Let's actually use it, set up some problems. Okay, oh, one more piece of vocab, sorry. Segments. Notation-wise, if you haven't seen it in geometry, you're going to see a line above. So segment AB is essentially talking about the line from A to B. Okay. Angles, you're going to see a couple of different ways. You can just notate it as just the angle itself, like angle A, and that implies the whole thing. Or we can be a little more specific and say angles BAD. That's not multiple, that's just one angle, so it goes from B to A to D. And essentially that middle letter is where the angle is at, so BAD. So that means that if you write angle A or angle BAD, that is literally talking about the same thing. This is the 3-letter notation, is just a little more specific. And it is really helpful when you're talking about a piece. So let's say I wanted to talk about just this angle. You could say D to A to C, right? Because it goes D to A, and then A to C, and the angle between is the one you want to talk about. You would say angle DAC to notate it. So just as a heads up, now that's the last piece of vocab. Let's apply some properties here. Okay, so it just says find the measure of all missing angles and sides. So first off, side, and you know the side opposite of it by theorem is congruent, so that's also 10, which means that if that's 18, the side opposite, also 18. All right, pretty straightforward. So if this is 79, opposite angle is also 79 degrees, right? And then the last but not least, if we're looking at these angles, we don't know what they are, but we do know they're congruent. The last thing you could say is supplementary angles, because we know that 79 up top, that means that 180 minus 79 is going to give us our remaining angle, in other words, 101 degrees. And then you know that opposite angles are congruent. There's your remaining angle. Okay, and you can also do that for this one. Let's fill this one in very quickly. 829, 113, and that would be 67 when we subtract it from 180. Okay, there you go. All right, now for slightly more complex stuff, let's get into it. So example 2, it says for the parallelogram, solve for x, solve for y, then give the length, meaning numeric length, no variables involved, of the segment from O to N. So first off, let's pick a variable. I like x, so I'm going to solve for it first. I see x is here, x is here. We're talking about sides, right? Those are opposite sides. Opposite sides are congruent. Congruent is another word for equal. So 6x minus 7 and 2x plus 9 are equal to each other. And that's how you do anything in geometry. Set up the relationship, and that's how you're going to get your equation to solve. So just get your x's to one side. We're going to subtract 2x and add 7. So we get 4x equals 16. Divide by 4, x equals 4. Now, if I want to know the length of segment O to N, we know x is 4. Literally plug 4 in. And then you find that 2 times 4 plus 9 is going to be my length of ON. Right? 2 times 4 is 8, plus 9, 17. That means the length of segment ON is 17, knowing that x is 4. All right, now the last but not least is to solve for y. That's the last piece we haven't done. Y is a side. You know sides, opposite sides are congruent, meaning that y plus 3 is equal to, let me do this in a different color actually, y plus 3 is equal to 12. Literally subtract that 3 over, y equals 9. You're done. It asked you to solve for x, for y, and find the length of the segment. You did. Congratulations. Moving on. Example 3. For the parallelogram given, solve for x and y, then find the measurement of angle ADC. There's a lot of different ways to do it. First off, let's label our diagram. The angle from B to A to D, A is the angle, right? The one in the middle is where your angle's at, is 110 degrees. A to B to C, you're at angle B here, that's 70 degrees. We could have found that using supplementary angles. A to D to C, which means the angle down here is 2x plus 40 degrees. And then B to C to D down here is 5y plus 15. Right? So we're solving for x and y. Pick one to solve for first, doesn't matter. Right? I'm going to do x because I can. There's 2 ways you can set this up. You could say opposite angles are congruent, or supplementary adds up to 180. Let's do congruent. Congruency, opposite angles are congruent for this first one, and I'll show you supplementary for the next. So that means that 2x plus 40, our angle is congruent, in other words equal, to its opposite angle, 70. Minus the 40 over, 2x equals 30. Divide by 2, x equals 15. There you go. Now our next one is solving for y. Now for this one, I'm going to use that adjacent angles are supplementary, meaning that 5y plus 15 plus our 70 must be supplementary, aka add up to 180. We could also use opposite angles are congruent. You will get the same answer either way. All right, so for this one, I'm going to combine my 2 numbers. So 5y equals 85. 5y plus 85, apologies, equals 180. Subtract that 85 over, 5y equals 95. And then you are almost done. Divide by 5, y equals 19. Solved, right? The last part is to find the measure, meaning the numeric value of angle ADC. Remember, this is that angle down there. So we need to know what x is, but fun fact, we know x is 15. You could plug 15 in, but keep in mind, we know that opposite angles are congruent, so you already know that angle ADC is 70 degrees. Right? If you have an easy path to take, I just take it. It's fine. Okay? All right, there you go. Example 4, use the parallelogram QRST as shown. All right, so QRST, that's what we're looking at. Perfect. Now solve for n and m, and then state various lengths. So when we're looking at this, first thing I notice is that we're working with diagonals. What theorem do we have that deals with diagonals? This one right here. Diagonals bisect each other, meaning that the length of our n plus 23 is congruent to our other length, the 4n plus 2. Remember, congruency means equal. That means that n plus 23 is equal to 4n plus 2. Okay, it looks a little terrifying, but parallelograms make it really easy with those theorems. All right, so I'm going to get my n's to one side, get my numbers to the other to solve. So subtract n, we get 3n. All right, get a minus 2 to move it over. So we get 3n equals 21. Divide 3, n equals 7. All right, and we can do the exact same thing for m. We know that diagonals bisect, meaning that our 2m minus 3 equals 11. Add the 3 to m equals 14. M equals 7 after dividing by 2. So you get m is 7, n is 7, and then we just need to find the lengths of QS, RC, and RT. Well, the segment from Q to S, right, Q to S is this whole thing right there, right? QS is 11 plus the 2m minus 3. Both of those are the length from Q to S. Now we know what m is, right? We know it's 7. We could literally plug that right in. Fun fact though, because you know those are equal, that's 11 and 11, which means you can also just say 22. But we could plug it in either way, you're going to get the same number. So 2 times 7, 14, 14 minus 3, 11, 11 plus 11, 22. There you go. All right, because you know that is 7. Now your next length is RC. All right, so let me take that out. From RC, just that little one right there. So equals n plus 23. You just happen to know that n is also 7. 7 plus 23, 30. Done. All right, now the last but not least, we have RT, which is the whole thing. Now keep in mind, if I know that this little segment here is 30, and this is congruent, that means that's 30 plus 30, RT equals 60. Or you could literally set it up as n plus 23 plus 4n plus 2. Plug in n, you'll get 60. Okay, example 5. Given the parallelogram QRST and the following information, solve for x, find the length of QC. So first off, we're looking at a couple of things. The length QS. QS is this entire length right there. And that entire length is told to be 112. C to S is just that length right there. And that is 2x plus 28. Well, keep in mind, diagonals, by your theorem, bisect each other, which means this is also 2x plus 28 there. So you'd say, okay, well, equation-wise, how does my two little green portions relate to the orange? Well, I know that 2 of my green portions, the 2x plus 28, equals the whole 112. Or how you could have set this up is you could have said that half of the entire thing, the 112, is going to equal the 2x plus 28. Okay, arithmetically, that's literally the exact same thing. In fact, in this step, if you want to divide both sides by 2 to make your life easier, you absolutely can, right? So whatever way you want to go about it, go for it. Okay, I'm actually going to distribute this just in case, because sometimes that's not an even number. Where it is even, yes, I would absolutely divide by 2. So we get 4x plus 56 equals 112. Subtract 56 over. All right, and we get 4x equals 56. Yeah, divide 4, and x equals 14. Okay, now the last thing it wants us to find is the length from Q to C. Q to C is our little section right there, which we know is the 2x plus 28. So literally, QC, the segment, is going to equal the measure of the segment. The measure of the segment is going to equal 2 times 14 plus 28. We know what x is. Plug it in. All right, so 2 times 14 is 28. 28 plus 28 is 56. And there's the length, the measure of your segment. And so you're done. Whew. Back page. Last examples. This is the last you'll see of anything and everything parallelograms. Okay, so first thing, I'm going to label these to make these really easy to tell what's going to happen to our next point here. So we have point A, -3, -2. A. All right, point B is -1, 3. All right, point C is 2, -4. And point D is the thing we're trying to find. Now, there's a couple places we could put it. It could be up here, all right, because that would form parallelogram. Or your parallelogram could be around, maybe around there-ish, all right, forms another. Or you could stick it down here, right? You have a couple of options. Now, how do you know which one it is? And this is why we labeled our points, is I know that A must connect to B. B must connect to C. Now, is it going to form a parallelogram if I connect there? No. Will it form it if I connect it over here? Still no. The only option is if it connects down there, right? So we just need to find out exactly where that point is, and we're good to go. So I know that parallelograms are made up of parallel lines, right? Parallel and parallel lines have the same slope, right? Remember, slope is rise over run. So that means if I can find the slope of either this line or this line, I'll be able to find my point. I'm just going to go for the slope of that line because I can. So it's going to be rise 1, 2, 3, 4, 5, run 2. That means it's going to be run 2, and 1, 2, 3, 4, 5. So that would be at -9 down there. Okay, and then connect. There's parallelogram. So it ended up slightly off the graph, but that's totally fine. Okay, there you go. Answer, you're done. Not too bad. Now the last is going to be as crazy as it gets, and that's going to be something with a quadratic. All right, so let's label this. We'll get into it. Q to S to R. So we look at S, Q, and R are right there, which means that we're not talking about the entire angle of S. We're talking about just that little smidgen there, QSR. That little smidgen is 139. Okay, and I'll do these in different colors to make it a little more obvious. Q to S to T, right? T is over here, Q's over there. We're talking about the little smidgen right there. And that is -18x plus 51. And then our last little section there, oops, there we go, is x squared minus 2x plus 86 at QTS. Now QTS is talking about the entire angle right there. So then that means that's x squared minus 2x plus 86. And it was like, great, now that it's all in the parallelogram, how does it relate? How can I find my angles? Well, you have 4 theorems, right? So let's kind of look at those. We're not talking about sides. So the first one's out of the running. We're not talking about diagonals. The third one's out of the running. So it's only opposite angles or adjacent angles. Those are your only options for these setups. So I'd say, okay, do I have opposite angles or adjacent angles? They are adjacent, right? Your opposite angle to S would be Q. You don't have that information. The opposite to T would be R. You also don't have that. You have adjacent angles, meaning that the angle of S plus the angle of T must add up to 180 degrees by your theorem. All right. So our setup for this is angle S, which is our first little smidgen, right? This thing plus that thing. In other words, those two combined is angle S. So 139 minus 18x plus 51, right? And that is angle S plus our angle T, which is x squared minus 2x plus 86. And that is our angle T equals 180 degrees. And then literally, that's your setup. You have an equation. Now we just need to relate those together. All right, so first off, x squareds don't combine with anything else other than x squareds. X's with x's, so minus 20x, and numbers with numbers. So 139 plus 51 plus 56, and all together, that's going to get us 276 equals 180. And then we just need to finish solving. Now remember, anything x squared tells you you're going to either factor or use quadratic formula or complete the square. Now I'm going to go for factoring, right? Remember, all of those are essentially want your numbers on the same side except for completing the square. So I'm just going to move it over regardless. Minus 20x plus 96. Right? And so to factor, I'm thinking of two numbers that must combine to give me negative 20, but when they're multiplied, give me 96. Well, that's negative 12, negative 8. And because you have positive 1 in front as that leading coefficient, you can go straight to your parentheses. Right? Set those parentheses equal to 0. To finish solving, add 12, x equals 12, add 8, x equals 8. The last thing to do is to make sure that your answers work, that they're valid, right? Keep in mind that when you have single answers, they're less likely to fail, but double answers, especially with quadratics, cubics, you name it, you got to keep an eye out for extraneous solutions, stuff that doesn't work. So it's okay. We're talking about angles. What wouldn't make sense in this situation? Angles of 0 wouldn't make sense, right? You can't have an angle of 0 that's like literally just a line. Okay, so no angles of 0. So can't be 0. Okay, what else wouldn't make sense would be negative angles, right? No negative angle numbers. So when I'm looking at that, I'd say, okay, negative angles rotate the opposite direction. That means you'd be out of your diagram. That's why negative angles are no bueno. Okay, so I look at that and I say, okay, now we plug them in, figure out what's going on. So let's try our 12 solution first. 139 is 139, that's not changing anything. So plug it into our second one. Negative 18 times x, which is 12, plus 51. All right, when we get that, we get negative 165. All right, because negative 18, let me double check that calculator. Yes, we get negative 216, right? Negative angle is a problem, which means 12 kicks the bucket. You cannot have that as a solution. All right, I'm not going to bother plugging it into my last one because if it fails any of them, it's going to fail, period. If it passed, yes, check all of them. All right, so that one's done. Moving on to the next. Let's see, I haven't used green yet. So now let's do the same thing, but for 8 as a solution. Negative 18 times, 8 plus 51. And then our 18 times 8 gives us negative 144 plus 51 is also an issue. That gives you negative 93. That solution kicks the bucket. And you're looking at that and you think to yourself, what? How does this work? If both of my solutions fail, did I do it wrong? No, that just means that a solution does not exist for this problem. The angles that were given to you are literally impossible to make this parallelogram work. That's all it means. Answer D and E, you're good to go. All right, that is everything parallelograms. Thanks for sticking around this long. Have a good day.